everyone, and welcome to Algebra 2. Today we're going to be doing section 4.3 on dividing polynomials. Before we do that, just want to go over long division in general. I know it's probably been a long time since you've done it, so let's talk about what long division means. If you had 31,427 and you wanted to divide that by 52, you'd probably just get out your calculators. But at one time you were taught long division. So I want to go over the basic format because today we're going to be doing that with x's, with polynomial functions. It's a little bit tricky. So the first thing you would do is you would see if 52 went into 3, which it does not. So then you'd say, does it go into 31? Which it does not. And then you'd see if it went into 314, which it does. And you'd have to figure out how many times. What times 52 would bring you to something close to 314, but not over 314. So you might try 5. 5 times 2 is 10. 5 times 5 is 25. 26, you're like, oh, I got pretty close. But then when you went to actually do it, you would have gotten 54. And that implies that you could have done one better. So I'm going to go ahead and erase my 5. I only point this out because you luckily will not have this problem with polynomial functions. And you would raise it to 6. 6 times 2 is 12. 6 times 5 is 30, but with the 131, ooh, that was just about as close as you could get. And then even though you might not put the subtraction sign in, you know to subtract. 314 minus 312 is 2. And then what would you do? You'd bring down 2. And when 52 didn't go into 22, you'd bring down again, but you'd have to hold this spot. You'd have to know that that was a 0. And then you'd be asking yourself, how many times 52 goes into 227, which is 4 times. 4 times 2 is 8. 4 times 5 is 20. And you're left with 19. Because again, even though most people don't bother to write it, you are subtracting there. So the answer to this division problem is 604 and 19/52. This is called an improper fraction, and this is called a mixed number. This is improper because the top is bigger than the bottom. This is mixed because it's partly a whole number and partly a fraction. So what we're going to do today is that exact same process, but we're going to do it with polynomials. So it's this divided by this, so we're going to put this polynomial on the outside. And then we're going to put this polynomial on the inside. And something that you don't have to do with numbers that I do want you to do with polynomials is I want you to make sure that, oops, I see that I'm not supposed to be cubed. I want you to put in a placeholder if there's missing a term. So 4, 3, 2, 1, x to the 0. Okay, that's going to make all the difference. So now your job is to figure out how many times x squared plus 3x plus 2 goes into 2x to the 4th. So there's a very easy way to do this. You take the first thing in the divisor, and then the first thing over here, and you divide them. 2x to the 4th divided by x squared is 2x squared. That gives you your first thing. So unlike when we were trying to do it with numbers, you might have a sense that 6 times 5 makes 30, but you didn't know if the 2 would make it too big. So there's a lot less guess and check here. Instead, you can just do the first thing divided by the first thing, and that'll tell you what you want to start with. So the most important thing I'm going to say today is stay in the right column. This is huge. If you stay in the right column, you're going to do great. So since I'm starting with 2x squared, I'm going to put it in this column. It's just the same thing that we did with here. We didn't put this 6 over on top of the 3. We put it on top of the number that we knew was going to get our answer. And now you're going to have to do 2x squared times this entire thing. Again, we didn't do 6 times just the 5, even though that made 30, we had to do the 6 times the 2. We even had to carry, which we won't have to do with polynomials, and then the 6 times the 5. So 2x squared times 2 is 4x squared. That's why we wanted that column. 2x squared times 3x is, 6x cubed. And 2x squared times x squared is 2x to the 4th. Now, while most people are really good at subtracting on a regular division problem, people are really bad about it here. So my recommendation is that you get a different color out and you put in your subtraction sign, because a number only needs one subtraction sign, but a polynomial needs one for every single term. And oftentimes people forget, if you don't switch the color and you forget the subtraction sign, don't expect any partial credit from me. So now this is negative 4x squared. This is negative 3x cubed, and this canceled, just as I expected it would. What is the next step in division? To bring down. So I bring down my 5x. And again, some people intuitively can see what times what will make 3x cubed, but if you can't, you can do that problem over on the side. Negative 3x cubed, just do the first divided by the first. Over x squared would give me negative 3x. So I know I want to put that in the x column, negative 3x, and I'm going to repeat this process. Negative 3x times 2 is negative 6x. Negative 3x times 3x is negative 9x squared. And negative 3x times x squared is negative 3x cubed. I'm going to draw my line. Now I want to subtract, which, because these are negative, that means I'm going to change them to addition. So again, I switch my color, and I'm going to change them to addition. This canceled. This gives me 5x squared. This gives me 11x. And now I bring down my 1. What times x squared makes 5x squared? Again, if you can't do it, you can write the first one that you're trying to figure out, divided by the first one over there, and that'll always tell you what goes in the next column. I multiply. 5 times 2 is 10. 5 times 3x is 15x. And 5 times x squared is 5x squared. I remember I get out a different color. I change the sign. And then I subtract. Subtract, subtract, subtract. Okay? Oh, I see a mistake, sorry. I was supposed to bring down a negative 1. So I'm bringing down a negative 1, which actually would make this a negative 11. Copy error. So what is the answer to my problem? It's 2x squared minus 3x plus 5 with a remainder of negative 4x minus 11 divided by x squared plus 3x plus 2. Just like that. So some people have a little bit of trouble with the remainder, but think about it this way. If you had 15 divided by 3, now that goes into it evenly, there's no remainder. 15 divided by 4, then it would go in 3 whole times. That would make 12, and then you'd have 3 left. And what are those? Those are 3/4. So it's the bottom number, it's the denominator, that is still part of the mixed number. Okay? All right, let's do another one. Don't worry, we're going to practice a bunch. Make sure you got it. So I'm going to write this as x minus 1. And this one, I don't need a placeholder. Every spot is represented. It goes cubed, squared, first power, and then this is technically x to the 0. Nobody writes that, but that's what you can be thinking about. Okay, so x cubed divided by x is x squared. So that's going to be my first thing that I write down. X squared times negative 1 is negative x squared, and x squared times x is x cubed. I change my color, and notice that this one subtracts and this subtraction becomes a plus. And the last time they all were minus or all were plus, but that is not the norm. And then I get that cancels. Ooh, and that cancels. So everything canceled. So I'm going to bring down my 2x, even though there's nothing here. And then I ask myself, 2x, that's the first, divided by x, that gives me 2. Now be careful. Even though I feel like I should be in this column, I got a 2, no x. So I'm going to move it over to this column. So oh, by the way, again, I forgot to bring that negative. So it's actually going to be -2. So why did that happen? Because two things canceled, we ended up skipping a column. And you don't have to write 0x here, but if it makes you feel better, you can write 0x here. It's up to you. But because I'm in this column, I'm also going to have to bring down the 8. And if you don't think of that, that's okay. You'll know it in a minute. When you do -2 times -1, you get +2, and you need a place to put it. And when you go to put it in the number column, you realize, oh, I guess I got to bring that number down. -2 times x is -2x. I personally always get out a different color. So I remind myself, I can look back at my work later and say, yep, I changed all the signs. And then these cancel as expected, and this makes 6. So my answer is x squared minus 2 plus 6 over x minus 1. If you divide this polynomial by this binomial, this is the answer that you'll get. Let's do the next one. X squared minus x plus 1, x to the 4th. By the way, if you want to try this one on your own, pause the video, see if you can do it. That's what I would be doing in class. I definitely would not be doing this next one for you if we were in class. If you're coming back to the video now to see if you got it right, if you didn't, then you probably forgot the 0x cubed. Plus 2x squared minus x plus 5. By the way, if you want me to jump straight to the answer, x squared plus x plus 2, 3 over x squared minus x plus 1. So if you got that right, great job. Okay, so x to the 4th divided by x squared is x squared. And now I distribute. X squared times 1 is x squared times negative x is negative x cubed, x squared times x squared is x to the 4th. I change the sign. This becomes minus, this becomes plus, and this becomes minus. I always change my color to do that. This cancels. This becomes x cubed, 0 plus 1. And this is 2 minus 1, so plus x squared. I bring down on general principle just the next term. Sometimes you have to bring down more than one like we did in the last one. X cubed divided by x squared is just x. So I'm going to put an x there. Now I distribute. X times 1 is x. X times negative x is negative x squared. And x times x squared is x cubed. I don't want to say, right? Change my color to make sure I don't forget to subtract every single term. Just trying to point out where kids go wrong. This cancels. This gives me 2x squared minus 2x. And now I bring down the 5. 2x squared, the first divided by the first, will tell you what to put next. And it's just a 2. I distribute. 2 times 1 is 2. 2 times negative x is negative 2x. And 2 times x squared is 2x squared. I changed my color to show that I've subtracted correctly. So when I look back on my own work, I can feel confident. This cancels, and I just get 3. So if there had been more, I probably would have had to skip a step because 2 things canceled. But my final answer is x squared plus x plus 2 plus 3 over x squared minus x plus 1. Okay? So I'm going to show you a shortcut that only works on certain problems, okay? I want you to put your pencils down. There's going to be numbers 4, 5, and 6 are going to let us practice this, but I'm going to use number 2 to show you. So I don't want you to try and write all over your number 2, but I'm going to write all over your number 2. So when you can use the shortcut is when you're only dividing by just x plus or minus a number. You'll notice that in number 1, you're dividing by an x squared and a bunch of other stuff. In number 3, you're dividing by an x squared and a bunch of other stuff. But if you're just dividing by x plus or minus a number, you can use a really cool shortcut. So this shortcut is called synthetic, so artificial, an artificial division. I'm going to take this number, not the negative, just this number, 1, and I'm going to put it outside a box. And in that box, I'm going to write the coefficients. So here's a 1. This is a negative 1. This is a negative 2. And this is an 8. And just like regular division, if I had been missing a spot, I would have had to put a 0 in. You're used to putting in the 1 instead of the negative 1. We've been talking about how we often look at this number as its opposite. So this would, if it was a graph, it would move right instead of left. So that concept is going to keep coming into play throughout your math career. Okay, here's how you do the division. First, you add. There's nothing to add here. This is really just a 0, but you can think of it as 0. So I add, and then I multiply. The outside of the box thing times this number. 1 times 1 is 1. And then I add, and then I multiply. And then I add, and then I multiply. And then I add. So that's the pattern. Add, and then multiply. And then put that answer, and then multiply and put that answer there. And then add, and then multiply. Add, and then multiply. And then what's cool is the reason that this gives you your answer is because if you look back on your answer for number 2, this last number will be your remainder, and then this will be your number, and this one will be your x, and this one will be your x squared. And if there had been a longer problem, the next one would have been the x cubed, and then the x to the 4th. So you do want to start at this end. You could try and figure out which this is. I'll just tell you it's always 1 less than where you start. So if you're x squared or x cubed, the first one's going to be x squared. But a lot of people just start from the back side, and that way they can say to themselves, remainder, number, x, x squared, x cubed. Of course, we don't write 0x. So the answer would be x squared minus 2 plus 6 over x minus 1, which is what we got doing long division. If you think you understood that, you can go ahead and do 4, 5, and 6 on your own. I'm going to quick write down the answers for you in case you'd like to try them. Number 4 is negative x squared plus x plus 3 plus 18 over x minus 3. Number 5 is x squared minus x minus 9. Or if you need to practice your long division, you can practice on these. But I'm going to do them using synthetic. How do I know that I can use synthetic? I know because each of them are just x plus or minus a number. All right, so number 4. I'm going to put outside the box a positive 3. It's always the opposite of what you see in there. And then I'm going to write down the coefficients. Negative 1, 4. There's no x term. Don't forget your 0. And then the number. Then add. This first one's a little silly because there's nothing to add it to. So some people say bring down, but I always just like to go add, multiply, add, multiply, add, multiply. Add, multiply, add, multiply, add, multiply, add. And then you can give yourself the answer. The remainder is 18. This is the number. This is the x. This is the x squared. And there's your answer. This is like one of my favorite things. So fun, right? All right, next one. I put a positive 2 outside the box. And then the coefficients are 1, -3, -7, and 6. Is everybody seeing where I get those numbers? Coefficients. So now I add, multiply, add, multiply, add, multiply, add. And you can already see, because I already wrote the answer, how I converted that. The -12 became the remainder. The 9 became the number term. The -1 became the x term, and the 1 became the x squared. I hope you're enjoying this. Last one. I always put the opposite of this number in this box, and then the coefficients. 2. Did you catch it? 0. If you're coming back to watch this video because you got this one wrong, that might have been the reason why. Add, multiply, add, multiply, add, multiply. Ugh, what is that? -51. So -58. And again, when you bring this down, this one becomes the remainder. This one becomes the number. This one becomes the number with the x. And this one becomes the coefficient of the x squared term. If it doesn't have anything, you'll have to put a little plus in there to differentiate. So that's synthetic division. Next up, the remainder theorem. The remainder theorem says that if a polynomial function is divided by x minus k, then the remainder is r is equal to f of k. That sounds so confusing. So I'm going to explain super easy what it means. It's actually amazingly cool. So not only does synthetic division allow you to divide without using long division, which already makes it awesome, but then on top of that, if you're given a function, if f of x is equal to -x cubed plus 4x squared plus 9, and you wanted to do f of 3, this is not that hard, especially if you have a calculator. You'd plug in -3 cubed plus 4 times 3 squared plus 9. F of 3 is -27 plus, let's see, 9 times 4 is 36 plus 9. F of 3 is 18. Do you see that number anywhere? It's right here. Are you ready for this? This is so great. If you're doing synthetic division on a polynomial, so here's the coefficients of the polynomial, if you put an x value on this side of the box, out will pop the y value. Okay? So on this one, this function, the original function, is x cubed minus 3x squared minus 7x plus 6. If I asked you for f of 2 and you didn't feel like plugging 2 in, you could do synthetic, and what would the answer be? -12. So they call it the remainder theorem because the remainder is the y value. And actually, I already wrote this on your notes. It's just that it's on the next page. The remainder is the y value. So it's just pretty cool. All right, let's do the examples that are actually given there for you. So first of all, if you never understand this concept, and a surprising number of kids don't, right up through calculus, I really have people struggle to get this. You can always just do f of -4. That's what evaluate means. The word evaluate simply means plug in -4. But if you don't have a calculator, plugging -4 into this equation could be challenging, right? So this is the same as plugging -4 into the box. So just to be clear, there's nothing wrong with doing it this way. Even on your test, I'm not going to require you to use synthetic division. Just on your homework tonight, I want to make sure that you understand that this concept is exactly equivalent to plugging a -4 into synthetic, and then out the other end will pop f of negative 4. This is the y value when x is equal to negative 4. So it's just pretty cool. Let's do it real quick. Add, multiply, add, multiply, add, multiply. What is that? Negative 388. Yeah. And then add negative 359. Okay. So I might have even used my calculator even for that. But there's a little bit less work, I think, than doing it this way. Let's see if the next one's any better. So your choices are f of 5, which is 4 times 5 squared minus 10 times 5 minus 21, or putting a 5 into here, 4, negative 10, negative 21, add, multiply, add, multiply, add, 29. So the function, if you plug in a 5, will give you 29. So if you did this math, you would get 29. So I know I don't usually do this in your notes. I try and show you every single example. But on this one, I am going to ask you to do it on your own. I'm going to be looking to see which way you did it. I am going to allow you to choose. But in the end, you should write f of 2 is equal to 50. Sometimes kids just box this answer. But it's important that you write this because it helps me know that you really know what's going on. That when x is 2, this function has a y value of 50. All right, 3 thinking questions for today. What is the value of k such that negative x to the 4th plus 5x squared plus kx minus 8 divided by x minus 4 has a remainder of 0? So I highly encourage you. This one's definitely one you can do on your own. You might want to pause the video and see if you can do it, but I will do it for you. A 4 goes in the box, always the opposite. And then you have negative 1, 0, be careful, 5, k, and then negative 8. So I start to go along. Negative 1, I add, multiply, add, multiply, add, multiply, add. So now I get k minus 44. But on this end, I know I want the answer to be 0, which means working backwards, I know I want this to be 8, because negative 8 plus 8 would be 0. So now you can ask yourself the question, 4 times k minus 44 is going to be equal to 8. Now your first instinct might be to distribute, which is, by the way, totally great. But I'm going to let you think outside the box a little bit. I would actually divide by 4 first. K minus 44 is equal to 2. And the math was a little easier. Add 2 to 44, and you get k is equal to 46. And of course, this is super easy to check just by putting a 46 right in there. On number 2, it says the volume of a rectangular prism is given by volume is equal to 3x cubed plus 3x squared plus 18x minus 8. Find the expression for the missing dimension. So the key to this problem is knowing that volume of a rectangular prism, which is a fancy name for a box, is length times width times height. So in other words, the volume, which is 3x cubed plus 17x squared plus 18x minus 8 is equal to the length, which we'll call L instead of question mark, times x plus 4 times x plus 2. So there are 2 ways to do this problem. Think about it if it had been, let's say, 48 is equal to length times 3 times 4. One way would be to multiply the 3 by the 4 first, 12L, and then divide. Or you could do 48 times 3 times 4. You could divide by the 3 and get 16 is equal to 4L, and then divide by the 4. You could do them one at a time. So both methods are perfectly valid. So I'm going to do it both ways, and we'll see which way makes the most sense to you. So let's start by multiplying those together. X, because I think that's how most people would do it. X squared plus inners and outers makes 6x plus 8 is equal to 3x squared plus 17, sorry, I keep doing that, 3x cubed plus 17x squared plus 18x minus 8. And so now to find the third dimension, I would divide, just like you would over here. You'd multiply those two together, and then you would divide both sides by 12. So x squared plus 6x plus 8. So fortunately, you know how to do long division now. You just learned it today. So let's go ahead and do that. X squared plus 6x plus 8 divided into 3x cubed plus 17x squared plus 18x minus 8. 3x squared divided by 3x cubed divided by x squared is 3x. So I get to start way over here. This is nice, right? So I'm only going to have at most two pieces to my answers. It's not as long a problem as it looks. 3x times 8 is 24x, and then 18x squared, and 3x cubed. Even though I'm doing a word problem and not focusing on division, I still change the color to make sure that I get the correct sign there. Now I have negative x squared minus 6x. I bring down the 8. And negative x squared divided by x squared is negative 1. Negative 1 times 8 is negative 8. Negative 1 times 6x is negative 6x. And negative 1 times x squared is negative x squared. I change the color to change my sign. And as expected, there really shouldn't be a remainder. This is an exact dimension. The length is equal to 3x minus 1. That's one way that you can do it. And it's a great way. And it's probably how most people think of. But just as a little note, you could divide by 3 and then divide by 4. And if you're wondering, why would I want to do that? Well, because if you just divide by 3 first and then by 4, or in this case, divide by x plus 2 and then x plus 4, you can use synthetic. And that might be more appealing to some of you. So let's do it that way. So I'm over here at this step, 3x cubed plus 17x squared plus 18x minus 8 is equal to length times width times height. So if I divide both sides by x plus 2, I can get this answer synthetically. So off to the side, I do 3, 17, 18, negative 8. I put my negative 2 in the box, add, multiply, add, multiply, add, multiply, add. So this division produces 3x squared plus 11x minus 4. And on this side, I'm left with length times x plus 4. Now I can divide both sides by x plus 4. Why would I want to do that? To get the L by itself. But I've chosen this method then because both times I can do the problem synthetically. Is it worth it? I don't know. It depends on how much you hate long division. So this method required FOILing and then long division. This method requires synthetic division twice. They're both a little bit of work. You just have to decide for yourself what's the most important to you. So this divided gives you exactly 3x minus 1, no remainder, which is the same answer as we got before. So two different ways. You can decide which way works for you. Last one, everybody. A polygon has an area represented by 4x squared plus 8x plus 4. The figure has at least one dimension equal to 2x plus 2. Draw the figure and label its dimensions. So it's actually only going to have two dimensions. It says polygon. They didn't want to give it away. But since it came out to be x squared, then we know that the other one is going to be something with an x in it. So 2x squared, I guess the point is that it's got to be length times width is equal to area. So 2x plus 2 times the width, or times the length, either way, is equal to area, which they said in this case is 4x squared plus 8x plus 4. So I divide both sides by 2x plus 2. Can I use synthetic? I cannot. So synthetic only works when you simply have x plus or minus a number, not 2x. But that's okay. The long division isn't terrible. 4x squared plus 8x plus 4. I look at my 4x squared and my 2x, I divide, and I get 2x, which I put in this column. 2x times 2x is 4x squared, and 2x times 2 is 4x. I change my sign and change my color to make sure I don't forget that step, which gives me 4x plus 4. 4x divided by 2x is 2, so I know that's what goes last. Oops, I didn't really want to, well, that's okay. We'll mix up the colors here. So that gives me 4x plus 4. I change my color, and I subtract, which gives me 0. So there's no remainder. The other side is 2x plus 2. And that's why they said polygon. They didn't want to give it away, but it is a square. 2x plus 2, 2x plus 2 are the dimensions of my square. All right, everybody. It is just extra practice if you choose to do it. But that's it for section 4.3. Have a great day.